Hello everyone and welcome back to mathMinutes. This video delves further into the world of ratios, and more specifically we'll explore part-to-whole ratios, scaling up ratios, and even how to seamlessly switch between different ratios. First up, let's quickly recap what ratios are. A ratio is a way of comparing two or more quantities. It shows the relationship between these quantities and is usually expressed as a fraction or with a colon in the form a to b, where a and b are two values. This can be thought of as a part-to-part ratio. For example, if we have a bowl of fruit with 4 apples and 6 oranges, we can write the ratio as 4 to 6, or simplified as 2 to 3. Now, let's break down part-to-whole ratios. A part-to-whole ratio represents the relationship between a specific part or quantity to the total. So that is a to a plus b and b to a plus b. In our previous example of the bowl of fruit, the part-to-whole ratio of apples to the total fruit would be 4 to 10, or simplified as 2 to 5. Let's consider an example. A corner store only sells black and blue pens. The ratio of black pens sold to blue pens sold is 13 to 5. What is the ratio of black pens sold to the total number of pens sold? We know that the ratio of black pens sold to blue pens sold is 13 to 5, so we add up both parts of the ratio to find the total. There is a total of 13 plus 5 equals 18 pens for every 13 black pens sold, so black pens to total equals 13 to 18. Now, let's discuss scaling up ratios. Scaling up a ratio involves multiplying both parts of the original ratio by the same factor. This gives us an equivalent ratio, which we can then use to solve various problems. For instance, imagine you have a recipe for a cake that serves 4 people, but you need to make enough for 8. If the original ratio of certain ingredients is 200 grams to 300 grams, scaling it up for 8 people would result in requiring ingredients in the ratio 400 grams to 600 grams. This ensures the proportions remain consistent, allowing you to create the perfect cake for your larger gathering. Let's work through another example to better understand this process. A farmer grows carrots and potatoes on a patch of land in the ratio 2 to 5. There are 1,200 carrots. How many potatoes are there? First up, let's work out the scale factor. We can do this by dividing 1,200 by 2, which we find to be 600. We then multiply the part for potatoes by this scale factor. So, 5 multiplied by 600 gives us 3,000. There are 3,000 potatoes. Sometimes quantities can change, which will then impact on a ratio. Consider a bag full of red and yellow marbles in a ratio of 6 to 11. There are 18 red marbles in the bag. If we were to add 3 yellow marbles to the bag, what would be the new ratio of red to yellow marbles? First, let's find the original number of yellow marbles. We write down the ratio as it is, so 6 to 11, and what it needs to be. Here we have the left side, the red marbles, to be 18, and the right side, the yellow marbles, is what we're trying to work out. Now, 18 divided by 6 gives us 3, which means if we scale our initial ratio by a factor of 3, we have 18 red marbles on the left side, and 11 times 3 equals 33 yellow marbles on the right side. So, there were originally 33 yellow marbles. Now, if 3 yellow marbles are added to the bag, then there are now 36 yellow marbles. The new ratio of red marbles to yellow marbles is 18 to 36. We can simplify this by dividing by the highest common factor, the HCF, which in this case is 18. This simplifies to 1 to 2. And there you have it, a comprehensive look at part-to-whole ratios, scaling up ratios, and changing between ratios. These fundamental skills are not only essential for academic success, but also for everyday situations where understanding proportions is key. If you found this video helpful, don't forget to hit that like button, subscribe for more content, and share it with anyone who may benefit. Thanks for watching, and I'll see you in the next video.